Okay, it's June 3rd, 2023, about 1:30 Pacific time. Eric and Hakasez are down in Tonopah, Eric Dollard's shop, and we're going to be looking at a slideshow here. Apologize for all the technical difficulties here, but that's all we're getting out of Zoom and everything else at the moment. And so the call from April, that's on YouTube. I'm going to be mailing out a link to that soon, and I'll be editing the other call, which was a walkthrough in the shop that may have some missing video in it, even though it has audio. And I'll do something with Adrian on that, or maybe we'll just wait until the 21st or something when you get here, and we can just redo that section live again and just splice it in. And so Eric's website is ericpdollard.com, and it's 501c3 nonprofit, and we're in desperate need of donations. That's what keeps the lights on and pays the bills, and helps to support the projects that are going on down there, which Griffin and Hakasez will fill you all in, and Eric as well here with the slideshow and other updates. The Energy Science and Technology Conference coming up. Let's see, I'm just going to bring up the page. I duplicated the conference stuff on emediapress.com. So let me do a screen share here real quick. Okay, so if that's showing on emediapress.com, you just scroll down and there's this conference ad at the top. Just click learn more, and that takes you right to the place where you can get tickets. So if you scroll down, it has the date, the details, who all the presenters are, and I recreated the conference schedule on this page, so you don't have to go to a separate conference website to see that. The schedule is pretty much 100% completed, locked in. I just recently added Paul Wheaton. He's known as kind of recognized as a world's leading authority on permaculture. And he's just over in Missoula, Montana, about 2.5 hours away. And he's going to be presenting on a truly solar passive greenhouse that doesn't even have a fan. And there's a Wufati design for passive, I guess, heating and cooling of homes. I'm not too familiar with it, so I'm going to be learning about it like everybody else. People who are familiar with permaculture, the importance of it for food security and everything. It's definitely something to look into. And there's also going to be a presentation by Jim Gale, Food Forest Abundance, which is also heavily focused on food security, because the upcoming issues we're going to be encountering about this food shortage they're trying to fabricate. And other than that, I think pretty much everything else has been on here for a while. There's only about 15, 16 tickets left. For the in-person tickets. If you click on get tickets in person, that'll take you to the next page, which is 15. Okay, so there's 15 tickets left. There's plenty of streaming tickets. There's actually a limited number of streaming tickets, but there's plenty left, 40. And the reason for limiting it streaming is once you go over a certain bandwidth, the price kind of goes up exponentially, from hundreds of dollars to thousands of dollars. It's kind of ridiculous, but anyway, plenty of tickets. And then let me bring up Eric's page real quick. So ericpdollard.com is the main website, official website for the work of Eric Dollard and EPD Laboratories, Inc. You scroll down, you'll see all these blog posts. Mostly Griffin has been keeping those updated. And in the main menu bar, there's this donate link right here. And again, the organization survives solely on donations. You can either mail checks or money orders to this address in Spokane, and I just endorse those and send those down to the bank in Nevada. And then there's a PayPal donate button, which is probably about how 90% of donations come through. We really need help with donations, whatever anybody's able to give. A lot of the expenses just went up. I mean, the building insurance just went up, like it just like tripled, literally, because they're trying to force us to have a valuation on the building, which is about 3 or 4 times more than what it actually has been, which is ridiculous. And they're claiming that's the replacement cost, but for that much money, you can build a brand new house instead of an, simple pole building or something. So stop the share here, and I guess we're going to go straight to you, Hakases, with the screen share.
Yeah, I guess I'll start screen share here, but as we get started, I kind of want to do a rough overview of what we were doing and what the whole plan was this week.
Great.
I know, so me and Griffin got there last week. We've been here about a week, and the project, it's always triage. There's more stuff to do than we have time for. But one of the things was bringing a couple coils that we could experiment with in the shop with a very good ground. The system that Eric has set up outside was not complete. The poles were set up, but we didn't have an RF deck that we could experiment on with a really good ground. There was a telephone pole that needed to be dropped a few feet and installed with only manual labor and a lot of sweat and tears. Let's see. We also had what is it? Justin's up refurbishing and modernizing the shack to we'll say good mil spec, good setup. And the other one was now that we had the coil and the deck and everything all triaged, then the goal was to start doing some rough experiments and seeing how they perform in the real world. So Griffin, Eric, do you have anything you want to summarize for the week?
Not me right now.
Griffin, so this was the we'll call this the VLF coil, and this was a replica of, I forget the exact specs. Griffin, do you recall this?
So yeah, so this design essentially comprises the semi-replication of the Bolinas Alexanderson loading coil, which essentially comprises multiple concatenated layers of a rather unique coil configuration. And in this case, this coil measures around 30 inches in diameter, when in fact the actual original Bolinas Alexanderson coil measured around 6 to 8 feet in diameter.
So it's a scale model.
Yes, well, of course, this design is more or less an experimental model, and we will be pursuing in the near future various designs and further replications of it for further analysis.
I was the one that put the stuff together, that basically built it as a kit. So we had the individual spokes, the rings, everything cut out, but we still had to assemble it, glue it, paint it, and everything once we're here. So you can see as we got through the first day was just getting a lot of this stuff together, jigsawed, all nice and tight, sealed against weather. There was another coil, which was might be known as the Topaw coil, which was a 160 meter ham radio coil that we've been working with for some time. But to help improve performance, I basically made a mod kit for it, which some 3D printed risers and then some polyethylene precise spacers allowed us to take the same coil form, but rewind it with much thicker wire in a much more consistent form and much more professional looking once it's all finished, that we were hoping would give us better results when we actually fired it up. And that's the 160 meter coil after it's been modified. It's using 1/4 inch, 100 feet of 1/4 inch copper tubing. Thankfully got a pretty good deal on those. And they're all spaced with the UHMW plastic, so that it shouldn't have the frequency, and it shouldn't load it down. It should have performed better than we were expecting. So I think that's the VLF coil. Another shot winding that. That was quite the monster. If I remember correctly, it was a 10 gauge wire and almost 20 pounds of 10 gauge wire in a straight line. What is it? 5 per Christmas tree element on the bottom, 5 on the top, and then there was 8 rows, so something like 80 turns. Griffin, anything adding on that?
Yeah, could you repeat that?
Just the almost 20 pounds of 10 gauge wire. So it's quite the monster once it's actually constructed and in place. And it's over, what was it, 30-inch diameter. So the function of this, when we started testing it, it gets down to about, what was it, 400 kilocycles unloaded with no
So
rings or anything
the
special.
standalone frequency of the coil apparatus was around 443 kilocycles. But of course, with ground loading, that went down to around 410, 400 kilocycles, give or take.
And then this is the coil form as it is. Unfortunately, it's such a low frequency. We don't really have transmitters that are built for that. So we did get some vector network analysis, and we got some rough idea on the operating frequency and the quality factor and things like that. But that was the part for the coil construction. So another part that was, I think, day 2 when we're starting on this was, you can see there were 2 poles that were set up adjacent to the ground, the large tank ground that's in the center. And the goal of that project was to get some, what would you say, get some beam supports across and make it a proper, what was it, proper secured telephone quality deck that we can use to put the coils on and do some proper repeatable experiments on. So it's just a couple pictures of what we're working on.
So for reference, these pictures essentially illustrate the attachments of the cross arms, which are on the poles and essentially support these cross sections which go across the cross arms. And upon this will sit a deck, which in the initial beginning comprised boards, but that was found very unsuitable. So pictures probably after here, we will see a completed version of it.
So when it's finally finished, that was the final system. And when we got it started the project, it was just 2 poles sticking out of the ground. So that system is complete. The deck is painted plywood in green. One of the test coils that's sitting on here. And then above that is a span of thick aluminum wire that serve multiple purposes, I suppose. Anything, Griffin?
So essentially the wire that's the old apparatus or this configuration, this aerial capacity to the coil also facilitates for other.
You're breaking up, Griffin.
Experimental somewhat, but nonetheless we're able to gather a decent amount of various.
Is that breaking up for you guys too?
Yeah, I should point
Yep.
out that there's an elaborate underground section of this, which is a 15,000 gallon tank filled with water. That's what you got on the bottom is there's like a concrete slab. And then there's the tank lid and the trunk that leads down to the actual body of the tank, and then the gravel for the proper drainage. And then you can see the aluminum cross buses that tie the various welded zinc covered iron wire pigtails that come off the tank collar coming up from the tank body. And that was getting around having the welded some very old telegraph iron telephone wire, which had a thick coat on the outside. So this telegraph terminates on the aluminum bus, and then there's four gauge aluminum conductors that act as basically a low inductance connection to the deck, where then the transformer neutral is connected to transmit into the ground. So this ground system has remarkable characteristics. It measures about 1 ohm DC resistance against the high voltage multiple grounded neutral in the town, which of course includes the substation ground itself. So you pretty much can take, that's one advantage of the multiple Y connection is you are connected to massive quantities of metal and ground rods, and that extends for thousands of square miles. So we could assume that that was a point of zero impedance. So 1 ohm's pretty good for this kind of stuff. I think it's probably better than just about anything anybody's got right now. And it was a massive project because prior owners of the building had cut holes in the tanks and cut the vents, and they just made a complete mess out of it. And I think we had shown in prior pictures somewhere that, you know, the work involved with digging everything up and hauling gravel. And but at any rate, now it's done. So this is what's called the telluric test platform, which is a completely adaptable structure. And as this progresses, it will become a permanent transmission fixture, which will put out a regular signal on the air at a certain frequency, at a certain power level, assuming that there's any means to get licenses or do any of that anymore in the present situation we have in this country. But we'll have to experiment with that and see if we can get a regular frequency and a set of call letters for this and put it on the air.
So the part on here was another
Just
couple
before
days.
you go on, just
Go ahead.
before you go on, Griffin, you broke up when you were talking about the elevated capacity, the T wire at the top there. Could you just repeat what you were saying about the T wire? That was quite interesting.
Yeah, so that connection essentially serves as two purposes. For now, in this photo, we're using it as an aerial capacity.
Yeah, the other purpose it was originally designed for is there's a the hardware of the high voltage insulators is grounded. We haven't done that yet. And the cross wire was going to have a piece of copper pipe slid over it. And then a section of low capacitance coax was going to go up to that and pick off. And that would be a true potential transformer connection to the top of the Tesla transformer, because to be doing your field strength measurements around the bottom, you're going to get various interfering influences with different parts of the coil and the ground system. And the only way to really measure the electrostatic potential of the coil is with the aerial pickup. But it also has the advantage of serving as the elevated capacity in a more fixed transmission or reception mode.
Right. Thanks, Eric.
Is that good? Do you want to talk about the part, which is the pole that we had to put in at the seismic station?
Oh, that was a harrowing experience. The pole was way too heavy for us to manage. And
So
there's really
the pole
no
that's
way-
on there, pole that's on there is somewhere between 600, 800 pounds.
Yeah, I don't know for certain how heavy it was. I would say it's an order of magnitude, 500 pounds. The poles that we normally use are ones that we dig up and remove, which have been out in the desert about as long as I've been alive. So they're kind of more dried out, and we don't have a problem managing those. In fact, we have to put one up, which I don't know if we have that shown in this or not. For the we're going to start the ultra low frequency antenna from the shack outward. So at any rate, we couldn't manage this pole. The other problem is the ground here is solid rock, and it's our experience has been just to dig a 3.5 foot deep hole for a guy anchor took myself and Justin, and I was in a lot better shape then. It took us 2 days to get down that deep. So the only way that we could do it here without a lot of expensive equipment, which isn't around here is interested in being hired for anything, and there's no more donations coming in to pay for any of that anymore. We just had to figure it out ourselves. So basically, what you're looking at that the truck's parked on and the standing pole and the pole we're trying to put up and all that particular area right there is all mine tailings. So that stuff was relatively soft, but it had a couple of 100-pound boulders extricated. And the question was how are we going to get this pole to go in the hole when it's way beyond our ability to manage it? So Justin contrived the structure to provide the leverage of the truck to get the pole. Here's where we're positioning the pole to get it ready for that process. And I think the frame is somewhere down the line here in photographs. There we go. The frame is under construction. So a very roundabout way to do it and expensive because we have to buy all that wood, but we had to get that pole up. The power company put their pole, our pole to connect to get power to the seismograph mine. And so one way or another, we had to get this thing up, and so we did. So I guess here's the final push here. We had to do some excavating to get it so the truck could back in. It was we were never really certain if we were going to be successful or not, but we were.
Just a
And
quick note,
Harold, go ahead.
the audio is cutting out a little bit, so maybe if you turn off your camera, generally the audio will come through a little bit better. I yield.
Ready to take a squat on us?
Still got me?
Yeah, we could still hear you.
Okay, that's good.
Can't hear Eric,
The other
though.
part, it's occasional breaking up. The other part about this was just as we were getting to the critical part with the truck pusher, the truck joust, finally got part of the hill dug out so the truck can lay level. And we're finally getting to that part to try to push it into the hole is when the weather decided to start cutting down at the same time. So it starts getting a little bit of rain and blistering cold, and then it started hailing just as we're getting to that little final push to drop the pole into the hole. So it was kind of interesting how as we were hitting the more chaotic and almost risky portions of the thing, the weather was almost following us end to end. And then, but lo and behold, we finally got it down there and got some rocks in there to help stabilize it. And as the project started to stabilize, the weather did too. So by the time we're done with one of the final pictures here, the pole on the left here is up and finished, and the sky's cleared up and everyone's happy. And 2 days and 2 days of just putting the pole up and more days of digging the hole, but it's finally finished and it's one step closer to being a completed project. So it was all worth it. So another one of the projects that I did want to cover was Justin's, one of his tasks up here is to more or less modernize, finish. Eric, you want to cover some of what's the goal of that project is? The shack upgrade?
Yeah, we lost it here, so we're kind of coming in late, but at any rate, we have a weather station at the end of our cable right of way, which is the old cable TV shack, which is basically the only one of its kind around for 100 miles. So a lot of services like to use this weather station, but it was pretty badly cobbed together, and then the people that installed it ran away, didn't want to be bothered, and so basically what we have to do is just pull everything apart and start all over again. So that's what we're doing now. The shack has to be made lightning proof, so that means that there has to be some kind of metallic shield to make sure the displacement current waves don't go crashing through and knock all the radios off, and wires were hanging everywhere and holes in the wall. And it just, it's just completely unacceptable. Became very unreliable. I do not have the vehicle complete yet that I need for driving up and down to get to this thing. So that makes it even more difficult. But now we're getting all that buttoned up. When we first got the shack from the cable TV company, it was basically just a collection of lumber getting ready to be take flight in the wind. It was quite a construction project just to get the thing stable again. And go back to the one you had before. The one of the racks.
Yeah.
Yeah. So that's what's starting. That's what's going to go in there. It's going to be done right. Everything's going to be properly shielded and grounded. Wires are going to be in conduit. There'll be an RF bulkhead, so no conductor will exit the structure without going through the RF bulkhead and the shield. So the base of the thing is going to be a completely shielded metallic bulkhead, so there won't be any external lightning influences or any of that, or stray emissions or what have you. And then everything's got to be in the racks, got to be properly grounded, and wires, neatly placed and all that, and made it so one radio doesn't interfere with the other. And so that's what we're engaged in now, on top of what we just completed with the Telluric test platform. So actually we've done pretty good this round so far. We got a major utility pull in, we got a minor utility pull in, which I don't think in the videos. And the shack is being finalized as we speak. And
Yeah, this was one of the earlier shots of the the cob installation, and it did work. But as you can see, the build quality is a little bit more cobbled together. Compare that to what's being worked on now, much more professional, long term, and rugged.
So that's what's in progress presently.
And then the last part is the experiments that we have been managed to do with the deck, the ground deck, and everything now finished. So with both of the coils that we have in place, we were able to take some measurements and get some rough numbers for both of the coils that are on hand. Griffin was able to take some measurements with the vector network analyzer, same thing, testing various parameters, whether the overhead aerial is not in place, or whether it's hanging near the system, affecting the capacitance, or whether it's directly shorted. Who wants to cover some of that, Griffin?
Yeah, so essentially the setup work notes.
You're breaking up a little bit. One more time.
So this picture demonstrates the
Still there? Okay, I'll take for a bit while he's coming back. So what's on the deck right now is the 160 meter coil. It's connected to the vector network analyzer, and we were trying both just to get some useful data, as well as get the rough tune to have an idea when we start to hook actual HF radio equipment to it, because to start trying to transmit and receive on it. So while they come into there, I'll keep going here. So once we had the rough numbers and some of the vector network stuff, we were able to start cranking up the power a little bit more. Okay, well, I'll keep going on here. So Griff, actually,
Just a question Hacker says before you just go on. What was the nominal frequency? What was the nominal series resonant mode frequency?
so the coil unloaded as it was approximately 2,400 kilocycles with the rings on it, but freestanding and nothing else connected to it. So it did need quite a bit to drag down the frequency, but actually you want Want to talk about this at all?
You were
So,
guys doing
okay.
the test, so you gotta kind of describe what you did.
So what, you guys hear me okay still? So,
Yep. Yeah.
so what we have here is when, yesterday afternoon, when we were starting to test the, higher power levels, on the deck, we have the 160 meter, coil that was, by itself about 2,400 kilocycles. On the power side, we have an ICOM, HF amplifier that would go into that band. It's rated for about 100 watts. We also had at our disposal a vacuum tube RF amplifier that would peak out around 500 or 600 watts if we needed to. And then we had multiple tuners on hand, but what seemed to work best for these experiments was a twin T tuner, MFJ 969, for matching the HF radio equipment to the coil. So those come out as a standard RF connector leading into a number 43 ferrite toroid with 6 turns on the primary going to the HF radio side and 2 turns running to the coil. On the high side of the coil, the long wire leads to the base of the Tesla coil. On the lower end of the wire leads to an RF amp meter, which then goes to this black wire, which is a thick aluminum bus bar, which goes down both sides and connects through the buses down to the very low impedance ground plane that Eric described earlier.
Mhm.
On the upper side from the Tesla coil, that leads from the lower ring to the lower rings of the coil through each turn of this. At the top of that terminates to the lower end of a variable air capacitor. This allowed us to drag the frequency down to something that we could transmit inside the ham radio spectrum. The upper end of the capacitor was attached to the thick aluminum T overhead that has the elevated capacity. So once this was all tuned up, we had some ability to operate within the standard ham radio band. And some initial tests, we were pumping out about 200 watts to verify that it could be detected some distance away. I believe it was five miles or so to the local.
6 miles of the PRC 47 in the car.
So
So
as
that in other words, is receiving with only 8-foot width.
yeah,
Now, the
so
signal got stronger as I got away. Another interesting observation was when I drove underneath
little
power
louder.
lines, the signal got weaker, not stronger.
yeah. So we were doing that. After that, the experiments we were doing carried on into the night when the band actually opened up. From there, aside from being able to use the fluorescent tubes to light the shack and help tune the system, we were able to pick up a little bit of sounded like audio, but we weren't looking for any long distance contacts at the time. It was more for calibration and see what we could get. So aside from playing around with a couple fluorescent tubes with a few hundred watts of the transmitter just to light up the night a little and have some fun. In addition, we had part of the team managed to drive some distance away so we could gauge the power that's coming out of, or we could gauge the efficiency and gauge the propagation. So we started with approximately 150 to 200 watts output with a low SWR tuned to the meter. Fairly significant, we had measured over an amp of ground current. But that may not have been, we had some weird readings on that. From going out, the sound was crystal clear out to 5 miles, out to 10 miles, and then to about 14 miles. At that point, instead of driving until you ran out of gas, we decided to start cutting the power to see what the actual propagation, how the propagation would be with the lower power. So we went from 150 watts to 100 watts with no noticeable difference, went to 100 watts to 50 watts with no noticeable difference, 50 watts to 25. It stopped registering on the SWR, but it's still crystal clear on the receiver. which if I remember correctly, was just an aerial, it's a car mounted aerial. It's
Right.
not designed for 160 meters in any way, shape or form. Kept cutting the power down to 10 watts, still able to clearly get it down to 5 watts, which was the minimum of the transmitter, was able to pick it up. And the only way we were able to get it down low enough that it wasn't detectable is by intentionally breaking the SWR of the transmitter. So SWR 8-to-1 was 8 to 1 with a 5-watt output, put us somewhere in the 1 to 2 watt range, which was just the bare edge operating capacity or operating reception. Any past that and it would drop out. And that was approximately 14 miles with no effective antenna on the transmitter and no antenna rated for 160 meters on the receiver. So
When you say, Hacker says, just to clarify, when you say no effective antenna on the transmitter, what do you mean?
The overhead aerial was acting as a load, but we don't have an antenna that's 160 meter quarter wave or half wave that you would normally see for that class of band.
Okay, you only had the you only had the coil. You only had the quarter wave coil.
We had the quarter wave coil and the overhead that was on there, but that was about 12-foot span, so it's not intended to be as an antenna. It's hard to gauge at this moment, but the goal was to have more current flowing through the ground than being radiated through the antenna. Unfortunately, our equipment, we have to make some changes to get better data for that in the future. This was more of a limit test to see what could be done with what we have. And the fact that we were able to get pretty significant results with less than 5 watts of power and really no optimizations beyond that, just generic equipment, I think is a good sign that if we keep moving forward and we keep getting stuff,
Right now, this thing's ready to be assigned to frequency and call letters and go on the air. With the coil that we're talking about now, we're ready to go. There's no point in fooling around anymore. Next step is get this thing frequency allocated and get it on the air. It's ready to go, and then do the reality test. I feel quite confident. The next experiment would be to, I don't think Bruce Gavin is with us right now, which is unfortunate because he's the other end of the line, is probably the most optimum time. Well, the first thing is he's ready to operate on this frequency at a moment's notice. So he would be at the other end. So it's about 3,000 miles away. We would do it at the most optimum time, and conditions for such transmission would be, it would have to be midnight. That's real midnight, not daylight savings time or Ronald Reagan time or whatever your silly phone tells you, but real midnight. Exactly halfway between here and there. And then see how well this operates in the normal, ham radio scenario, which will probably be voice because most people don't know telegraph anymore, but telegraph's about 10 times as effective. It would be desirable to do that. So, and then I have a Navy transmitter here, which unfortunately was abused by being left sitting in a junk pile up in the desert for 20 years, but it's restorable. That's capable of a continuous commercial service of 1 kilowatt sideband or CW, and that gets restored and connected to this transformer, further weatherized and things tightened up a bit, get the deck up higher to keep people's fingers off of it, and then it's ready to transmit. Now the problem here, of course, is the NEMV energy, and they're a big problem for everything we do here. I don't think even they fully understand the magnitude of the problem, but the high voltage neutral is connected to the metal siding of our building, which is customary practice in today's utility scenario. So we have a nice big 200 or 300 square foot interference capacitor sitting behind the coil. which is not making it easy to receive because we have a China digitized business as a neighbor that shares the same transformer bank as us. And it's quite effective in jamming. You cannot use your AM radio around it. You can't talk on your CB radio within 500 feet of the facility. So it's a remarkable feat of Chinese technology to make sure that none of this stuff works. We're kind of stuck with that. So this will probably end up just being some kind of transmitting beacon for experimental purposes, just to see where it can get picked up and where it can't get picked up, and leave it at that as a kind of like the weather station on top of the hill. It's just basically a data type of situation, and it can transmit data, of course, within its bandwidth constraint. So it can be used as a information broadcasting system. So it has a lot of radio possibilities, but it is not possible to receive here.
And I think that's what we have so far for the projects that are ongoing. So I guess, Griffin, do you have anything to add to?
No, that pretty much covers what we've been doing over the past week. So we've had decent success with multiple projects, including the Telluric test platform and the pole adventures, as we showed prior, but nonetheless, I mean, even through a struggle, we were able to come out with some decent success and decent analysis.
So I guess with that, we'll pass it back to Aaron and see if we want to do Q&A, if anybody has any questions or interested in this.
Sure.
Well, it sounds
So-
like a productive week.
Oh my God, out of for 7 days, it's more like 6 weeks.
Sounds very good.
Okay, so Rick, let's see, I just saw a question typed out from Rick Enzer. For us non-engineering types, could you please explain what you were trying to do with this setup?
Duplicate Tesla's transmission system.
To replicate the work of Tesla and Alexanderson and Steinmetz,
Make it functional.
because really nobody's done this since their era. A lot of the stuff hasn't been built since the 1920s and 1930s. It's completely unexplored technology, but a lot of the data and a lot of the stuff is there for us to follow.
Yeah, and Rick, if you look at the pictures of these what do you call it, Alexanderson coil? Nobody else is doing that. Everybody else is using what they're going to call, typical Tesla type coils. And so this is a completely different.
Completely different. So whereas it's a normal ham radio setup, but instead of the ham radio trying to radiate out into the air to be picked up that way, we're radiating to the ground using the ground as an antenna. So the aerial is not meant to radiate. So we're working with a completely inverted form of radio. So we're not sure what's even possible at this rate. We know things that are conceivable, but it won't be until we start getting more effective data and more propagation studies that we know what's possible and what isn't with this system.
Right, and over the past couple of experiments where we have multiple people drive out to see if they could receive the signal, although we do have a decent ground system and the intention is to transmit through the ground, nonetheless, there still is the space component or the Hertzian component, which is radiated out into space, but nonetheless, we are not using a conventional antenna, which essentially changes the circumstance. So of course, this requires further analysis, further detailed analysis to really quantify just what exactly is the Hertzian versus the telluric component. And of course, in such a setup such as this, where we're not using a conventional antenna, we are obtaining some rather interesting results, which may or may not conclude that it is not necessarily a Hertzian component.
Well, I'll point out that none of those terms have any meaning anymore. This is a whole nother area. And to start looking at it in terms of electromagnetic theory and, no. Now, the only thing that I'm looking at here is how good does it work? That's all I care about. It's an engineering situation. There's a whole scientific world that will open up around it. But my simple-minded objective is to build things that work.
And nobody's done this.
And all Tesla coils have become is just some kind of big phallic symbol of electrical discharge
Toys.
that accomplishes absolutely nothing. And it's fortunate that that's all they can do is make sparks, because if they ever figured out a way to stop the sparks and to have the thing not discharge its energy into a useless flame, the zero sequence component would completely annihilate all solid state devices in the entire neighborhood. It would be a glorious event that they'll never achieve, because the whole goal, even though it's not to make the sparks, that's all they can think about.
Well said.
Let me read a couple of these questions here. Okay, so can be, so I assume that the ultimate benefits are much longer range with lower power, so more efficient energy or energy transfer. So
It might fit with caloric with seismic forecasting. It might work with communication. It might work with studying the ionosphere or studying the interior of the Earth.
But basically, if following the line of reasoning of Tesla and figuring out what the conditions are to get certain modes of transmission, which require very critical balancing between a lot of different energy storage factors that cannot be calculated in any way to make things even more difficult, is a transmission system. Basically, this thing would be unaffected by any nuclear wars or anything technological wipeout, because it's just too basic. There's nothing really to go wrong. And it doesn't rely on the ionosphere or any of these other things to any great degree when it's operating the way it's supposed to. However that is, we don't know what propagates where or how, but in Tesla's mind, if this thing is to be effective in operating in his conception of transmission, the transmitter coil would power the receiver that the receiving coil is listening to, just like the old crystal radios, and they would not need any source of electricity. They would derive it from the transmitter site. Now that's like a long ways off, and things aren't particularly moving too fast here because there's really no money for any of this kind of stuff. And society has collapsed, and within a year, it won't be possible to even get the simplest materials. So we'll just have to see. I don't think it'll ever happen in my lifetime, but the two people standing beside me will probably live longer than I do.
okay, from Partha, here's a question. Can the TMT be modified to work without any wire, without any single wire or ground connection? Or does the longitudinal type system always need a ground connection?
Well, there could be other types of longitudinal systems that don't, but this system is based on the one wire concept, where you have a true current flow, not an electromagnetic surface condition or skin effect or any of those kind of things. I call it the J.J. Thomson current, because he was the one that first came up with that idea that there's an actual current flow within the metal, not the electrons or any of that, because that wouldn't work. And that is a longitudinal flow. And Helmholtz is so little known about him, but from Tesla's account, Helmholtz had also entered the idea of that type of current flow. And again, that would have to go through something, which would be, the inside of a metallic conductor or a column of ionized gas. Tesla had all these different ideas, but just to do it through free space would require a completely different structure that I can't I can't get that off the top of my head right now, how that would actually work. But it is conceivable, but that is not what this is.
And let's see, is transmission through the ground impacted by soil quality, water content, etc.?
Oh, vastly.
Yes.
In fact, there's like two completely different modes. There's one, the conduction mode, like we have here, But then where Griffin's at, earth conduction is not possible because the entire geology there for, 12,000 feet above sea level and probably, 30 miles down inside is all just one big chunk of granite. So,
It behaves more as a dielectric.
yeah, so that's actually advantageous in the Alexanderson system because I learned from the Bolinas station that all the so-called grounding terminals of the Alexanderson antenna system were not all tied together to station ground, but were isolated. So the situation that Griffin has can transmit in a different mode in the ground because the ground is a dielectric. Where here it would be thought of in terms of some type of conventional current concept. There it would be strictly electrostatic. And when you're using the Alexanderson system, you do not want a good ground. You want the opposite. You want it to be a dielectric.
Okay, Patrick is saying he joined late and there going to be a replay to watch the full call? Yeah, I'll have it edited and put on YouTube, and that'll go out in the newsletter. But I want to put them out in sequence. So the one from April is actually ready to launch. I'm going to put that out onto the newsletter here pretty soon. It's already edited and ready to watch. The one in May, we did a walkthrough at the shop, my shop here in Spokane, of all the updated project and everything. And we might have to wait until Adrian gets back here in Spokane and right before the conference to be able to redo that one, put that one up, and then we'll put this one up. So yeah, they're always recorded and made available on YouTube. Let's see, Steve Jackson is asking, SWER single wire earth return 50 hertz power systems are used in the Australian outback, maybe 5 kilometers with earth return. Is this related?
No. No, in fact, actually, it's the bane of all of this work is the idiocy of using the earth as one lead of the transmission system. By doing that, it completely eliminates any possibility of receiving earth signals. It's just wipes it all out. So that's what's happening in this country with the double Y, high voltage, low voltage, neutral tied together. And then the Chinese jammers at the load end is doing the same thing here. We have a problem. There could be as many as 1 million volt amperes of stray harmonic electricity flowing in the earth. That makes it that we cannot do the frequency or voice frequency earth receiving here out of the ground. It's impossible. So but basically, in places like Australia, well, their behavior there, the COVID carnival kind of indicates you would expect them to do something like that.
Okay. Let's see, there's a comment and a question here from Partha. I see a contradiction between J.J. Thomson's ether versus Tesla's ether. Thomson believed in Faraday tubes in solid ether, but Tesla believed in gaseous ether. Can you tell me what's your take on that? And can Faraday tubes exist in gaseous ether?
Well, here's the thing about the ether. That's another one of those misused words. Nobody really knows what the meaning of it. The best thing to call the ether, it's like the genie in the bottle. It's the first step of physical creation. Whatever you want it to be, that's what it is. So you pretty much have to leave it at that point. One person's ether is not going to be the same as another person's ether, and it's not resolvable.
Okay. If anybody else has any questions, suppose you can type it in, or down at the bottom of your screen, there should be a reactions option. And under that, you can click raise hand, and that'll give me a little symbol so I can know how to, or I can unmute you and you can directly ask it. And again, the Energy Science Technology Conference, that's going to be coming up July 5th through the 9th. So literally only 1 month from now, it's going to come up pretty quick. There's 15 tickets left. If you go to emediapress.com and scroll down, you'll see the ad for the conference. You click that button and that'll take you to the page with the full schedule, all the other details, and then you can either purchase the in-person ticket or a streaming ticket if you're not able to make it in person. So there's 15 in-person tickets left, and there's plenty of streaming tickets, and that'll be right here in Spokane, Washington, at my shop on the north side of town. Here in a few weeks, we'll be organizing and making space in there and getting that all set up. And if anybody has any questions, just email me at the info@emediapress.com. And then again, I want to mention that Eric's website is ericpdollar.com, and that's the P for Paul, Eric's middle name. So ericpdollar.com. EPD Laboratories Inc. is a 501c3 nonprofit charitable corporation. So it's all donations are tax deductible. It's based out of Nevada, and the donations help to pay the bills and support the organization and all this kind of research that you're seeing in these slideshows that Haka says has been sharing. Just about all that is made possible by donations. So you can see that it's all these donations are going to where they're supposed to be going, and that's to further this type of research. Any other questions or anything on your side, Adrian, that you want to update us on? Or
no, I don't have a great deal to update this time. Mainly my preparation is for the conference now. So I've been putting the finishing touches to the generator system that I'll be bringing there in my suitcase. Also looking at the completion of the presentations for the various things at the conference. So that's been the main work for me in the last couple of weeks, and will continue probably right up to just before the conference. So that's everything for me, Aaron.
okay. Let's see, I think there's another question here. Why Steinmetz Heaviside never spoke about longitudinal waves?
Why Steinmetz and Heaviside never spoke about longitudinal waves?
Well, Steinmetz wouldn't, how would you say, Steinmetz would kind of obfuscate things and not really say what he meant or what have you. So you wouldn't get him to say one way or another. Heaviside just got a little too married to Maxwell, and consequently just pushed aside anything that did not satisfy the electromagnetic boundary condition, which of course, completely shut out the other side. But that's not to say that a lot of Heaviside's mathematical developments aren't applicable on both sides of the equations. As a matter of fact, they are. The Heaviside equation is adaptable to any kind of condition. But the Heaviside wanted to stick with the practical issue at hand, which was long distance telephone and telegraph transmission, and anything outside of that, and all the fantastical mathematical hallucinations which were so popular in his day, which finally gave us, the theory of relativity as the crowning achievement of the whole mess, if you could call it that. All those guys were so wrapped up in that stuff back then, and increasing mathematical complexity, that they unfortunately wasted all their energy on that, not on things that could have been better utilizing that energy.
Okay. Let's see, this is kind of off topic, but I'll ask it anyway since it's the last question here, and then we can probably wrap it up if there's nothing else you guys want to add. What's your take on the Great Pyramid?
Well, that has nothing to do with what we're talking about.
Is it possible to rejuvenate a smartphone battery? I have to keep the smartphone connected to the charger all the time.
Try it.
Yeah,
Let me-
that's not really related either, but if you drain your phone completely and charge it all the way to the top, and then drain it all the way down to the very bottom and charge it all the way to the top a couple times, sometimes that kind of helps. But those lithium batteries are not really a good technology. Okay, well, I guess if there's no other questions or any final thoughts, Eric or Griffin or Haka says, or
We're all kind of in a state of exhaustion right now, so on top of the Digimam, so it's kind of QRU here.
okay. So I guess that call's about an hour since we got started about 20 minutes late because I couldn't even get into the Zoom account to get started. So I'll get this on YouTube probably right after the conference, or at least whenever I get the May one out. So, and I'd recommend everybody go to emediapress.com/energy times. And that's the free newsletter where most of the announcements go out. And also we can share a couple other websites. One is griffingBrock.com. I'll try to get a subtitle in here when I edit this, but griffingBrock.com is Griffin's website, and he keeps that regularly updated with the progress of all his experiments. And also he has a PayPal donate link on there, and you can see that the donations also are absolutely going to these experiments, and he's sharing his progress. And Adrian's website is am-innovations.com.
Hyphen Innovations, yeah.
Okay.
.com.
And that has there's a lot of resources in there for a lot of these topics. And you know, might as well mention the vector network analyzer that Haka says and Griffin are using to analyze these like Alexander coils and stuff down in Tonopah last year. Adrian presented on that. I'm just kind of getting my feet wet using those, but it's a valuable tool that anybody into this should really look into. And the one that Adrian specifically uses, he compared it to a what used to be $100,000 VNA from Hewlett Packard from years ago, and the performance is comparable for, you know, maybe about a $400 unit. Literally is working about as good as a $100,000 Hewlett Packard unit. So I'd probably stay away from those little $100 jobbers, you know, like on Amazon. I've seen the refresh rate is real slow. They're kind of clunky and everything. And so that's definitely a valuable tool. And Adrian also has a donate link on his website, and he's shared, you know, there's a lot of videos, a lot of pictures, a lot of posts on there. And then of course, on ericpdollar.com, that's a wealth of resources right there. There's a link in the main menu bar, I think free papers, and there's some free videos, and then of course the blog posts Griffin's, you know, keeping updated on there. We have there's a new booklet that's going to be coming out on Amazon and as a download. What were we calling that, Griffin? That 4-phase pamphlet. It's kind of an abbreviated version of what Eric will be presenting on at the conference, which is the 4-phase, which
and polyphase power.
Yeah.
okay. I just have to finalize checking some copyright stuff on some pictures and stuff used in there before it's published, and I hope to be able to have the paperback available for the new release actually at the conference. And then of course we're all going to be having the presentations available right after the conference, and all the past presentations, those are all on emediapress.com. And I think with that, if there's nothing else, we can go ahead and wrap it up. And I think, let's see, June 3rd right now. We had to skip last week just because it was better to do this while Griffin and Haka says we're in Tonopah. So 1, 2, 3, around the 24th, maybe tentatively plan on June 24th for the next call.
I mean, since we're going to be very close up to the conference and
Oh, yeah,
Eric's
yeah.
going to be up at the shop, why don't we maybe do the next one after the conference, Aaron?
Okay, so maybe like the 17th or something, because you and Eric both are gonna be
Yeah.
here in Spokane till like the 23rd or something, right?
Yeah, that's right.
Something
Yeah.
like that. Okay, so yeah, maybe 17th, that'll be a. Oh, no, this is June. Okay, hold on.
A couple of weeks before the conference.
Okay, so June 24th is 3 weeks from now, and then. So you're saying don't do one before the conference?
I was saying, do we really need one just before the conference?
After makes more sense because it's more about what we've done and what we're planning.
Yeah,
Yeah.
okay, so July 5th through the 9th is the conference, so,
Are you gonna be there early or staying late?
I'm going to be there. I'm going to arrive. I think the 3rd of July, but so just before the conference starts. But I will be staying there for 2 extra weeks after the conference.
yeah, I think the
We have a-
23rd.
Yeah, it's about the 22nd or 23rd. I think we have a program of work to do with Eric.
Because somehow won't receive me.
Yes, speak louder.
Is it picking me up? Yeah, well, then why don't we, if you're not gonna be there on the 24th, then why don't we just do another one of these on the 24th, Aaron? Because I'll be up there then and something will be going on.
Yeah, because you're gonna get here about the 21st, so.
Right.
So yeah, we can just stick to the 24th and then do one right after the conference, maybe that following
Yeah.
Saturday,
Right,
like the 15th or something like that.
yeah.
Okay, yeah, that'll work.
Because
Because
then by the 15th, then Adrian and I will probably have, solid material on the Colorado Springs duplication.
yeah, so in 2019, Eric presented on the Colorado Springs replica as a 20 to 1 scale model replica. And there's going to be some, I guess, kind of taking that experiment to the next level with the same coils and everything. They have to, some of the windings have to be redone, and then put some higher power in there and a few other modifications and whatever. And that'll practically be its own kind of demonstrate or presentation, really. Might as well be like part 2 of Colorado Springs, and that'll come after the conference. So we'll probably record that and make that available. So, okay. We'll just plan on the 24th for the next call, and then the 17th or whatever, that may around the 15th. That's the following Saturday after the conference. Probably have quite a few updates, and we'll go from there.
Okay.
Sounds good.
Okay, well, thanks
Sounds
for
good.
joining, everybody, and we'll see you all in about 3 weeks. Okay, take care. Have a good weekend.
Thanks, Aaron. Thank you.
Okay, see you.
Bye-bye.